Thank you for joining this lesson. We're going to continue with uniform circular motion, and we're going to see circular motion in a vertical circle. So a vertical circle is whereby the circular path, when it is tried to be observed, it is trying to trace a vertical plane. This is vertical circle, such that along the circular path there is a time the body is at the most bottom part, we can call it A, and as it continues moving it goes to the topmost part, it can be called B, and there are times it is horizontal to the circular path such that it can be at point C or D. So this one is called a vertical circle, a circular path placed such that as the body moves on the circular path, there is a time it is at the most bottom, other times it is at the top. So I want us to compare the weight of the body and tension and centripetal force at those different positions. And we can start with point B. At B, when the body is at B on this path, the weight of the body, as usual, the weight, which is mg, is going downwards. And also because this is the center of the circle and the string is held here, the string on which the body has been attached is held at the center, then we can also say tension on the string is also acting downwards, such that the resultant force, which will be the centripetal force now, is the resultant force of these two forces, and because they are going to the same side, then the resultant force, which is centripetal, is given by the sum of the two forces, tension and weight. Tension and weight of the body. We know that the centripetal force is given by mass times v squared out of r, which will be equal to tension plus weight, which is given by mg. We can make tension the subject of the formula and say that tension at the topmost part of a vertical circle is given by mv squared out of r. Then we subtract mg because mg has to come on the other side and it be subtracted. Therefore, at the top, you can say at the top, tension is the minimum. Tension is the minimum, since it is the difference between centripetal force and the weight of the body. So this can be tension minimum. Actually, it can be written like that. Tension minimum is given by that formula. We can consider again when the same body is at point A. When it is at point A, because the rope is held at the center, then the tension is acting towards the center, but as usual the weight of this body will act downwards, such that now resultant force will be the difference, such that we can say at point A the resultant force, which you're calling centripetal, will be the difference between the two forces. It is important we master that in case the weight of the body overcomes the tension which is going to the center, as weight acts downwards, then the body can lose or can break off from the circular path. If weight of the body overcomes tension, then the body can break from the circular path, and therefore we say that tension is greater than mg, so that the body remains in the circular path. Therefore, we take tension and we subtract the weight of the body, which is mg. Therefore, to have tension on one side, we can bring mg to this side and it be added, and we know that Fc is mv squared out of r. Therefore, we add mg. Because this one is a summation, then we can say at the lowest point, tension is at the bottom of a circular path, which is vertical. We say that tension is maximum. Tension is maximum, such that this one can be written as tension max. So tension maximum is given by mv squared out of r plus mg. So that is how we do it. Since we had said that Fc can also be given by mr then omega squared, mr omega squared, when we replace v squared, then we can say the same formula can mean that tension maximum is given by mr then omega squared plus mg, which means that consequently the other formula here can also say that Fc equals to mr omega squared plus or minus mg. At points D and C, since the weight of the body is still acting downwards, the weight of the body at D and C is acting downwards, it doesn't affect the action towards the center. It is independent. And at that point we say that at C and D, centripetal force will just be equal to tension. Therefore, at points D and C in the vertical circle, centripetal force, which is mv squared out of r, gives us tension. Or simply, tension can also be given by mr omega squared, which is equal to T. So that is how we can get tension. It is important to notice that when the circular path is horizontal, so on a horizontal circle, the tension and the centripetal force behave like positions D and C, such that uniformly, because the circular path tries to trace a path which is horizontal, then we usually say that at any given moment along the circular path which is horizontal, tension is uniform. It's not like in the vertical circle where tension varies. Tension is uniform and it will be equal to the centripetal force. This one will be equal to mv squared out of r, which is still the same as mr omega squared. So that is how we get tension at different positions for different types of circles. Kindly subscribe to this channel. For any consultations, follow this conduct. Thank you and God bless you.